Dear students, today we will start with the next chapter, Chapter 7, Coordinate Geometry. To understand the concept of this chapter, you must have some previous knowledge, that is how to calculate the horizontal distance and the vertical distance. For that, I would like you to see the second figure of the figures reflected here. This one is the second figure and this one is the first figure. So children, you will concentrate here on the second figure. So if I want to calculate the horizontal distance, that is the distance between A and C, I will first write down the coordinates of A, that are 4 and 2, and coordinate of C are 10 and 2. Now children, just take a minute and observe these coordinates very carefully. You are able to notice that y coordinate is not changing whenever we are moving horizontally. When we are moving horizontally, y coordinates remain unchanged. So y coordinate is not changing here. If y coordinate is not changing, that means distance can be calculated just by subtracting the coordinates of x, that is only by subtracting abscissa, as abscissa only is changing. So you will find out the distance by subtracting 4 from 10. Therefore you have used moved 6 units. And you know children, we never consider negative sign when we are talking about distance. So whether you are subtracting 4 minus 10 or you are subtracting 10 minus 4, you will write down the distance only by the number. You will not use the sign. Sign only indicates the direction in which you are moving. So children, this is 6 units. Similarly, if you are moving from vertex A to vertex B, that means you are moving vertically. You are moving vertically upward. So when you are moving vertically, children, in that case, you will first of all write down the coordinates of A, write down the coordinates of B, visualize them very carefully. This is 4 and 2 for A and 4 and 8 for B. So in this case, you have seen that abscissa is not changing at all. Abscissa is not changing when we are moving vertically. Only the change in ordinate is visible. It is 2, and when you are writing the coordinates of B, it is 8. So that means only by subtracting 2 from 8, you will get the distance, vertical distance. So that is 6 units. Getting children? So in this way, you are able to find out horizontal distance and vertical distance. No formula is mandatory. Is that clear? But if I want you to calculate the distance B and C, write down the coordinates. C is there anything that is not changing? So you will not find anything which is not changing. The ordinate is also changing. The abscissa is also changing. Both are changing. That means we cannot calculate it the way we have calculated horizontal and vertical distance. We need a formula. So we will apply Pythagoras theorem to find out the distance. BC can be calculated by calculating AB square plus BC square under the root using the Pythagoras formula. Now the same formula, since we want to find out the formula, that means we have to, we will not be specific in taking the coordinates. We will take general coordinates. So let us take a triangle PQR. The coordinates of Q will be x1 and y1. You know, you all are able to get the coordinate. If this is x1 and this is y1, then the coordinates of Q are x1, y1. And if I want you to write down the coordinates of R, you will say they are x2 and y1. And if I say you to write down the coordinates of P, you will say this is x1 and y2. Now, children, I want you to find out, write down this distance, horizontal distance. Horizontal distance, you are clearly able to see that the coordinate of y is y1 here, here, and y1 is here. So it is unchanged. Therefore, only the difference between the abscissa will give us the distance between Q and R. Therefore, the distance QR is equal to x2 minus x1. And if you want to find out the distance PQ, there you are able to see that x coordinate is not changing, only y coordinate is changing. Y coordinate, that means only ordinate is changing. Therefore, the distance PQ will be calculated by subtracting y2, by getting y2 minus y1. Now we want to find out PR. So we know perpendicular distance, we know horizontal distance, base distance. So children, by Pythagoras theorem, PR square is equal to QR square plus PQ square. That means put the value of QR is x2 minus x1, put square here, then PQ is y2 minus y1, put square here. And if you want to get PR, remove this square, it will convert into square root when you transpose that side. So that means this will become the distance formula, and this formula can be used to find out the distance between these 2 points, whether they are horizontal, whether they are vertically apart, or whether they are diagonally apart. In all the 3 cases, this formula is applicable. For example, if you want to take the distance between this, then this will be x2 minus x1, that means 10 minus 4 whole square, and y1 and y2 are same, so this bracket will become 0. So even horizontal distance can be calculated by this formula. If you want to find vertical, see x1 and x2 both are same, so this bracket will become 0, and this will become 8 minus 2, that is 6 unit. And if you want to find out the diagonal distance, then that means 10 minus 4, that means 6 square, and then 8 minus 2, again 6 square. Therefore, that is 36 plus 36. Getting, children? So now we are able to calculate this formula, this distance BC, by using the formula that you have used, that you have derived, that is x2 minus x1 is 6 unit, so this is x square, and y2 minus y1 is 6 square again. So children, this will become 2 into 6 into 6, that means 6 square root 2 units. So all types of distance can be calculated using the distance formula. Now let's So this is the beginning of exercise 7.1, where you need to find out the distance between these 2 points. We are doing first question, second part. So these are the 2 points given to you. You have to find out the distance between these 2 points. So children, if you want to find out the distance between these 2 points, I will consider that the coordinate of the first point are x1 and y1, and coordinate of the second point as x2 and y2, children. Now it's a lots of confusion whether to subtract -1 from -5, or to subtract -1 from -5, or -5 from -1. So children, just take 1 minute. Out of these 2 values of x1 and x2, just find out which one is greater. So in negative value, you know that the smaller is always the greater one. So subtract the smaller from the bigger. So -1 minus -5, because 1 minus you have in the formula. 1 minus in the formula, 1 minus in the value of x1. So these two minus are coming together, will make it plus. So this is minus 1 plus 5 whole square. Similarly, among the two values of y here, find out which one is greater. 7 is greater, so you will subtract 7 minus 3 whole square. Okay. Now this is 4, and when you subtract again you will get 4. So 4 square plus 4 square, that is 16, plus 16, that is 32. Factorize it to simplify, you will get 4 outside the square root sign, and the answer is 4 square root 2. Now we will find out the distance between these 2 points. Here also there are two values of x. This will be treated as x1, y1, and this will be treated as x2, y2. Now, in the formula, you have to write down, write down the difference between x2 minus x1. Again, take a minute, try to find out among these two values which one is greater. So positive value is always greater than the negative. So that means A is greater. From A, you will subtract minus A. A minus from this formula, and again the value of x, this value is again negative. So two negatives will make it positive, and therefore you will have A plus A. Don't think ki we have to subtract this one from this or this one from this. Always subtract the smaller from the larger. Okay, बड़े में से छोटा घटाइए. Don't bother x1 minus x2 or x2 minus x1. Since a square sign is there, you will always get the same number. It doesn't make any difference. Okay, children? So this is a plus a will become 2a. Similarly, out of these two y's, consider which one is greater. So this b is greater. b minus करना है उसमें से ये वाला, तो b minus minus b, that means plus b, and therefore it is 2b whole square, and therefore it is 4b square. And children, 4 can be taken common. So inside you are left with a square plus b square. Now 4 will move out as it has twice 2. Therefore, this will become, twice a square under the root a square plus b square. Now we will solve one more question of the exercise. That is third question. Determine if these 3 points are collinear or not. Children, first of all, we will assume that they are collinear. And if they are collinear, they will be in a straight line. A, B, and C, they are in a straight line. And if they are in a straight line, we are clearly able to see that if I add this distance AB plus distance BC, that will definitely equal to AC. Is that clear? So now we will find out the distance AB. We will find out the distance BC. We will add these two distances, and then we will find out the third distance AC. If the sum of these two distances AB and BC is coming equal to AC, we will say that these 3 points are collinear. Otherwise, we will say they are not collinear. So first of all, we have to find out the distance between A and B. Must write down the formula once so that you should not lose your marks for not writing the formula. Once in a question, you must write down the formula. So first of all, you write down the distance formula. Then children, start from here. You have to find out the distance between A and B. Out of the two values of x, this is the first value of x, this is the second value of x. You have to first choose which one is greater. So 2 is greater, subtract 1 from it. 2 minus 1 will be 1, and square of 1 is 1 only. And out of the two values of y, again you will choose the bigger one, the larger one. The larger is 5. Subtract 3 from it, that will be 2, and square of 2 is 4. So that means 1 plus 4 is equal to square root 5. Similarly, if you want to find out the distance between B and C, these two values of x, you will select the greater one. So that is 2 minus minus 2, that will become 4. Square of 4 is 16. Then out of two values of y, you will select the greater one. So 3 is the greater one. Out of 3, you will subtract minus 11. 3 minus minus 11 will become plus 11. 3 plus 11 is 14, and square of 14 is 196. And when you add the two, you will get 212. Factorize it, you will get 2 times 2, and then 53. That this 2 will move out, and therefore the distance between BC is twice of the square root 53. Now we will find out the final distance A to C. A to C. Among these coordinates of A and C, take the two values of x, select which one is greater. So 1 is greater. From 1, you will subtract minus 2. 1 minus minus 2 will become plus 2. That means 3 ka square, that is 9. And now 5 minus minus 11, that is 16. And square of 16 is 256. Add them up, it is 265. When you factorize, you will get 5 into 53. Nothing can be taken out, so that means this is square root 5 into square root 53. You may keep it like this only, but just to make it clear that they are not moving out of the square root. So now AB plus BC, add these two distances that you have calculated. So they are also cannot be added further, cannot be simplified further. You learned it in class 9, children. So this will remain as it is, square root 5 plus 2 times square root 53. Whereas AC is square root 5 into square root 53. So that means you have seen that the two are not coming equal. The two are not coming equal, children. Therefore, we can say AC is not equal to AB plus BC, or we can say that ABC are not collinear. That's all for this video. And solve more questions related to distance formula from exercise 7.1. I'll be taking few more questions from the exercise in my next video. All the best.